Hey everyone, and thanks for being here. Today we are jumping into the TryHackMe Snort challenge. If you are new to network security or want to get hands-on with intrusion detection systems, this is perfect lab. You know, Snort is a intrusion detection system and intrusion prevention system as well, and it's a powerful tool for network traffic analysis. I will be walking through the process of analyzing the packet capture files and writing custom snort rules to detect attacks. If you are ready, let's get started. Okay, guys, this is the task 2. After we started the virtual machine, this is the virtual machine here. The task 2, let's create IDS rules for HTTP traffic. Answer the questions below, navigate to the task folder and use the given packet capture file. Write a rule to detect all TCP packets from or to port 80. From or to, not from and to, from or to port 80. What is the number of detected packets you got? You must answer this question correctly before answering the rest of the questions. So we want a rule to detect all TCP packets from or to port 80. Okay, so let's open the command line and navigate to the task folder, which is the task 2. cd disk. We have the exercise files. Okay, so this is the task 2 folder. Let's navigate to this folder. Let's copy it and paste it here. And let's see what's inside this folder. We have the local rule and we have the packet capture file. So let's open the local rules files to write the rule. Let's use this command gedit and the file name. Let's open it. Okay, yeah, we can delete these and start from 1. So we need to write the rule to detect all TCP packets from or to port 80. Alert TCP any. We can 80 here and any. Yeah, we can write here the message TCP port 80 traffic. Okay, and the ID like that, and the revision you can say 1. Okay, so this is the rule. Let's save it and let's run this rule against the packet capture file that we have here. This file. Okay, so the question is, what is the number of detected packets you got? So let's run the command. C and the rule file, which is local rules. It's A and 4. We can add the B. Read the file. This file. Okay. Let's run. Okay, so we run the rule to detect all TCP packets from port 80. We write the rule to detect from, and we get 88. We get 88 alerts. Let's try the 88 here, and it's the wrong answer. Okay, so from or to port 80. Let's open the rule file one more time. Sorry, sudo. Okay, so if we put like both direction, we like this, and we save it. And let's try this time to see what's the output is gonna be. So we got the 164, 164, and submit. Okay, so this is the answer. Yeah, we just need to make the both directions, and we will get the all TCP packets from or to port 80. Okay, now investigate the log file. What is the destination address of packet 63? So 63. Let's use the N option so that we can get the packet 63. I believe, yeah, this would be the best option that we can do to get the exactly the packet 63. Okay, so let's use the command. Okay, first let's open the let's open the file. Yeah, now we have this log. We have this is the log file. We have two log files, the first one and the second one for the packet. We need to choose the right one, the right snort log. Okay, so let's sudo snort yeah, I don't know what's going on. Freezing. Oh, great. Let's refresh. Okay, great. Now the log file. Let's read this one. Yeah, let's read this one, and maybe we can use the V and N 63. Okay, so this is it should be like the last one, 63. And we let's see the destination address. Destination address. This is the source address with the port, and this is the destination IP address, and this is the destination port. So I think this one is the destination port. Let's copy it here and try. Okay, so that's it. Investigate the log file. What is the ACK number of packet 64? So yeah, using the same way, we can just change the N and write the N64. Let's navigate to the 64. Okay, so this is the last packet. So yeah, this is the 64, the packet 64. ACK number. The ACK number is this one. You can see here. This is the ACK number. Let's copy it. Paste here and submit. Okay, correct answer. Okay, investigate the log file. What is the CQ number of packet 62? Yeah, also the same way. Just we need to change the N option to 62. Let's try this out. The last one is the 62. Okay, the CQ number. This one. Let's try this one. Copy, paste. Okay, great. That's it. Investigate the log file. What is the TTL of packet 65? So we need to, in the same way, change the same command. But just change the N option 65 and see the TTL. Okay, so this is the last packet, which is the packet 65. TTL is 128. So let's see, 128. Okay, that's it. Investigate the log file. What is the source IP of packet 65? What is the source IP packet 65? Are we in these 65? Yeah, 65. So we don't need to change anything in the command. just let's investigate the packet 65 source IP, the source IP. So this is the destination, and this is the source IP, and this is the port. We need just the IP address. Paste it here and try it. Source IP, source IP, source pass here. Source IP. Okay, great. So investigate the log file. What is the source port of the packet 65? Yeah, this is the IP, and this is the port. Source port. Let's try this out. And correct. So, yeah, this is the task 2. Yeah, it was about the HTTP traffic. This is the task folder. It's to this folder. Okay, let's check it out. Okay, so we have the local rules files and the packet capture file. Okay, so the question is, write a single rule to detect all TCP port 28 traffic. Okay, so let's open the let's clean this and write the TCP, the protocol, any okay, this is all TCP port 21. Okay, any and the port 21. Well, this way we use the any traffic to port 21 and from port 21. And a message, let's say port 21 traffic. The ID 1000001 and the division 1. Yeah, well, I think this rule is good to go. Let's save it, exit, and what is the number of detected packets? So let's run the packet capture file against this rule to find out the detected packets. Sudo snort. The rule file is local rules. Let's use the V, and first let's use the A, full, and the option L to log the output. Let's use L. This is the packet capture file. Let's copy, paste here. Okay, so what is the number of detected packets? 307. Let's try this out. Yes, this is the correct service name. Okay, so we need to investigate. Let's use this command to investigate the log file. This command to investigate the log. We use the R to read, and let's use the div option so that we can get the full packet dissection and like the header and the payload. Okay, so let's just see what's the snort log name. Okay, so this is the log file. Let's use this sudo snort and the file. Let's paste it here. Oh, sorry, paste it here. Okay, no. Okay, and let's use the there. Okay, the output of the packets. Like we can just take 10 packets and yeah, so that we can investigate easily. And okay, so the FTP service name, FTP service name. So this is the packet. Investigate here. Okay, FTP. Can check here. This is the hex format, and this is the, oh, okay, so look, 220 Microsoft FTP service. Microsoft FTP service. So, okay, let's write this down here. Microsoft FTP service. Okay, so that's it. Yeah, that's it. This is the FTP service name, Microsoft FTP service. Great. Now, clear the previous log and alarm files. Deactivate. Comment on the old rules. Write a rule to detect failed FTP login attempts in the given packet capture. What is the number of detected packets? So first, let's clear this out. Clear. And we still have the alert in the snort log. We can remove them. Use this command. Remove file. We can use. So we can write this. We can copy this. We want to remove this and this. Okay, let's check. Okay, so they are removed. Now we need to open the local rule file to deactivate the old rules. Okay, we can deactivate it by add the hash like that, like it's a comment. So now the rule is just a comment. So we deactivate the rule. Okay, we need to write another rule to detect failed FTP login attempts in the given packet capture. So to do FTP authentication flow. So yeah, we can use the each failed FTP login attempt prompts a default message with the pattern 530 user. So this is what we want to add to the content inside our rule. So we can try to filter this out and see what's the output. And TCP any 0.1. So yeah, we need to yeah, we put this login attempt to the client. So so guys, we need to yeah, to use the content option in the rule to filter the failed login, or the yeah, the failed login of the FTP. And this failed login is the direction of the traffic should be from the port 28 to the client. So from the server to the client. So the source port should be 21. This is the source to the client. This is this. So it's this. This is the message that like the login incorrect. So let's write the rule here. Any. So the source port should be 21, and the direction like this. So this is an inbound. This is inbound inbound traffic from the server to the client. From the server, the port 21 to the client. And message. Let's say FTP maybe failed. and after that we can add here the content. We can add the content, which is 530. So this is the rule. Single alert TCP any 21 to the any message. This is the message content, the ID, packet capture file. Sudo snort local rules a full, and let's read this. Read the file. The file name is FTP. Yeah. Okay, what is the number of detected packets? We can see the number here is 41. Okay, correct. Okay, clear the previous log and alarm files. Deactivate command on the old rule. Write a rule to detect a successful FTP login in the given packet capture. In the given packet capture, what is the number of detected packets? What is the number of the detected packets? Okay, let's clear this. Okay, let's remove the old snort log and alert. Okay. And the alert. Okay, great. And let's open the local rule file. Sorry, not this one. Okay, we can activate this rule by adding the hash of the hash file. So let's add a new rule. Let's write the new rule to detect successful FTP logins in the given packet capture. Well, the FTP logins, the message should be contain the number, I think, 331, because this oh no, let's see, oh, okay, this is before the 331 is the number before, like the login. But if the login is successful, so the message contains the 230 exactly. So we need to add the content with the number 230 to the rule. So let's write this alert TCP any 21 any and the message. Yeah, maybe we can add the message, maybe FTP login. You can add whatever you want, no problem here. And this ID 101, okay, and the one. Yeah, just a reminder that we have to change the ID if we have a multiple rules. You know, if we have more than one rule or multiple rules, like each rule should be like has a different number. So for example, if we have another active rule here, and this one is like this one has the 1000001. The other one should be 1000002, for example. So we have to change the ID. Okay, so let's. Oh, we forgot something here. We forgot the most important thing is the content. The content. Yeah, as we said, 230. Okay, and yeah, this should be, I think, good. Okay, let's save it, and let's run the command. This. Yeah, the same one. Okay, so what is the number of detected packets? As we can see here, it's 1. Let's try this. 1. Oh, correct. Okay, it's clear. Let's clear this and remove. Yeah, remove this. Like, we just need to change the file name. Okay, now it's clear. We need to deactivate the previous rule as well. And yeah, we can activate it using the same method. Okay, write a rule to detect the FTP login attempts with a valid username, but no password entered yet. So what is the number of detected packets? What is the number of detected packets? So in this task, in this rule, we need to write a rule to detect the login attempts with a valid username, but no password entered yet. So in this way, I think we need to add the 331 yeah, exactly, 331 password. Yeah, the message after entering a valid username, we will get a message containing 331 to enter the password. Before entering the password. Yeah. So let's write this alert TCP any 21. Okay, let's do it this way. We can copy this and just change the, yeah, here we can say FTP, for example, password required. Okay, the content here should be 331. Okay, yeah, we don't need to change the ID here because it's just the only rule here in the file. These files are these rules are like deactivated. Okay, let's save and run the command. So the alert 42. The alert 42. Let's try what's the number. It's 42. Okay, great. Clear. Let's clear. And we can remove these two files. This is the log from the previous rule. Yeah, we can remove them and deactivate the rule. Yeah, let's deactivate this one, last one. Okay, great, and start with a new rule. Write a rule to detect the FTP login attempts with the administrator username, but no password entered yet. no password entered yet. So I think here we need to add two. We need to write two contents. Yeah, and this is the first one, administrator, the username, and the other one, which is the no password entered yet, the 331. Okay, so we can copy this and place it here. Required. Okay, we can add the FTP. Login, maybe FTP. We can say here login, FTP login. Attempt. The content here exactly, and we can like keep this content and add the other one, content, and we say it at administrator. Yeah, so the administrator here and semicolon. Yeah, exactly. So let's save it. And run the read command. Okay. The alerts 7. So let's try this. 7. Exactly. Yeah, this is the correct answer. Yeah. Task for writing IDS rules. PNG. Let's create IDS rules for PNG files in the traffic. Answer the question below, navigate to the task folder, use the given packet capture file, write a rule to detect the PNG file in the given packet capture, investigate the logs, and identify the software name embedded in the packet. So we need to write a rule to detect the PNG file in the given packet capture. So this is the task for folder. Yeah, it contains the packet capture file and the local rules file. Let's open the local rules file. And write the rule to detect the PNG file in this packet. In the packet, we need to add the option content to the rule, and inside the content, we should add the 8-byte signature of the PNG file, because the PNG file starts with the 8-byte signature in hex format. Yeah, we need to add it in hex format because we need to detect this file in the packet. So I did a search and I got the 8-byte signature, which is in hex format. It's about it's about the PNG file, like it's a unique signature in hex format, which is the .png. Yeah, but we need to add it in hex hex format to detect it and detect it in the packet capture file. So let's write the rule TCP detected, and sorry, this one, yeah, PNG file transfer detected. No, this. Okay, and the content. Yeah, the content should be like this. The 8-byte signature is 89050 4E 470D 0A 1A and 0A. Yeah. So this is the 8-byte signature in hex. Yeah, which is mean .png in ASCII code or language, if we can say, and the SID. One. Okay, so I think this should be good. Let's save and run the packet capture file against the rule like this. Okay. There's an error here. Okay, so there's an error. Let's check. The content is content 50.4447. I can't see any mistake in this one. See local rules A4. Oh yeah, we have an error here in the command, so we have to add the hyphen. Yeah, sorry. Okay, so this is the alerts. We can see like that we have one alert and okay, so we need to check here. Yeah, okay, so this is the snort log. Let's investigate the log. Let's investigate the log to get the answer. Okay, so we have one packet. This is the packet. The question is investigate the log and identify the software name embedded in the packet. If we can read here, this value is readable. This is in hex format, and this in a ASCII format. So we can check here. Text software, text software, Adobe image ready. Okay, so maybe Adobe. Let's try this. Adobe, Adobe image ready. Yeah, that's it. Yes, this is the software text. It's a text software. Adobe ready. Yeah. Okay. So clear the previous log and alarm files. Deactivate command on the old rule and write a rule to detect the GIF file and the given packet capture. Okay, so let's clear this. Clear this. Oh, sorry. Okay, it's clear and remove any log or alert here. We can clean them. Let's copy this. Okay, and the snort log. Okay, removed. So now we need to activate the previous rule. Let's activate this one. We don't need it anymore. And start with a new line to write the required rule. So the rule to detect the GIF file in the given packet capture. Okay, so we can write alert TCP any the message. Yeah, this message maybe. Oh, sorry, the message. We can add here maybe whatever you want. The content should be we know that the GIF files start with like two versions of there's two versions of GIF files. Yeah. The version 1 starts with GIF 87A, I believe, and the second version starts with GIF 89A. So 87 and 89. So it's GIF 8 for sure. It's GIF 8. So we can write the content like maybe GIF 8 yeah, GIF 8. Let's try this out. And okay. One. Okay, let's try this. Save. And let's run the packet capture against this rule like that. Okay. So let's just go down. Alerts 4. We have 4. Okay. We have the log. We can read the log using this command. Yeah, we can use this command. We need to change this. There. Okay. Let's copy this file. We need this file. Okay. So investigate the logs and identify the image format embedded in the packet. So we as I said before, we have two versions, the GIF 89 and the GIF 87. So the format that we have here is GIF 89A. Let's try this out. And that's it, the correct answer. Yeah, exactly. Okay guys, task 5, writing IDS rules about Torrent metafile. Well, writing the Snort IDS rules to detect Torrent metafile or Torrent file. Torrent file is a small file that contains metadata about files and folders to be distributed via the BitTorrent protocol. And this torrent file might be used to distribute malware, viruses, and for that we will try to write the rules to detect the torrent file. So this is the virtual machine. Let's navigate to the task folder, cd, yes. The task 5, torrent metafile. And we have the local rules file and the torrent packet capture file. Okay, now we need to write the rule. Let's open the local rules file. And write the following rule: alert TCP yeah, the content should be .torrent, I think. Yeah, .torrent, so that we can detect the torrent file. Content.torrent, and let's add no case, so and SIT. Okay, this one is 0 here. Okay, I think this rule now should be ready to save, and let's run the this rule against the packet capture file. Yeah, the file is Torrent packet capture. Let's paste it here and run. Okay, so this is the output. The alerts 2. So what is the number of detected packets? Let's try the 2. Correct. Investigate the log alarm files. What is the name of the torrent application? So now let's investigate the snort log file. This is the snort log file. Let's read it and find out what's the application name. Let's use this. Okay, let's investigate and look into the packet application BitTorrent. Application is application. Okay. Correct. So the application is BitTorrent. Now investigate the log alarm files. What is the MIME multi-purpose internet mail extensions type of the torrent metafile? The multi-purpose internet mail extensions type. So we can look here to find out the MIME, which is, I believe, application X BitTorrent. Let's try this out. Yeah, correct. So this is the multi-purpose internet mail extension. Investigate the log. What is the host name of the torrent metafile? The host name. The host name, I think. Let's try this. Look, the host here, torrentbox.com. So tracker2. Let's try this out. Tracker2 dot torrentbox.com. Correct. This is the correct answer. Now let's go to the task 6. Task 6 about troubleshooting rule syntax errors. Let's troubleshooting the rule syntax errors. Answer the questions below. In this section, you need to fix the syntax errors in the given rule files. You can test each rule set. You can set each rule set, sorry, with the following command structure. So this is the command that we can do a test after we fixing the syntax errors of the rule. The rule file is local one rules file and make it work smoothly. Okay, what is the number of detected packets? So after we fix the syntax error, we are supposed to get the right output, which is the number of the packets. Okay, so let's clear this and navigate to the exercise file, and see here we need the folder, this one. Okay, yeah. Now let's see. Okay, so we have like seven files, seven rules file, and one file. This one is a packet capture file. Now let's see the first one, local one rules. Okay, so this is the rule that we need to try to fix it. Alert TCP NE. This is the source, the source IP, source port, destination IP, destination port. Okay. So let's try to make a space here first and check the other things. Everything looks good. So let's save and try run this. We can run this command. Yeah, sudo snort. See, we need to run the local one rules, okay, and the packet capture file, which is this one, mx-1.packet capture. Okay, and console. We use the console just to see if we can get the output. So just a test for the rule. Okay, so the alerts we got actually 16 alert. Let's try the answer here. 16, is it right? Yes, correct. Sorry for the sound. Okay. Now, fix the syntax error in local 2 rules file and make it work smoothly. Okay, what is the number of detected packets? Let's see the other one. Let's open it. It's local 2. Okay, so this is the rule alert ICMP any any troubleshooting. Okay, so I think the source IP is missing. So alert. This is the protocol. We need to add any here. Okay, and see if there is any other error. Okay, so let's save it and try to run this command. We need just to change the rule file, which we have to use the joke. Now we got an output. We have 68. 68. Let's try this out. Okay, so this is the correct answer. This means that the rule is working without any problem. Fix the syntax error in the local 3 rules file and make it work smoothly. What is the number of the detected packets? Okay, so let's see by the same way. Let's just change this to 3. Open. Okay, so we have here two active rules. The first one, okay, it's syntax error. Okay. Alert has to be any message. Okay. TCP. Any. This is any 80 and port 443. Okay, message. This is the message, and this is the ID. This is here. Okay. Well, if you have noticed that we have the same ID for both roles. So I think we need to change one of them. This it can, because it can be like the same ID for both roles. So let's I can't see any other syntax error. Let's save and try to run the command. Just we have to change this, the rule file to 3, and run. Okay, we got the output, and we have 87. Let's try this. 87. Correct. Okay, fix the syntax error in local 4 rules file and make. Okay, let's check the rule, the local 4. Also, we have two active rules. Alert ICMP any message. Okay, ready. Okay, alert TCP any. This is the port TCP any support. Okay. Okay, I think we have to change this. This is not correct. To semicolon. Okay, let's save it. I think it's good to go. Save it and run the command. Change the rule file to 4 and run. Oh, we still have an error. Let's check. Oh, yeah, we have to change, yeah, the same error as the previous one. We have to change the ID. Yeah, they should, each one of them should have another like, or maybe a unique ID, if we can say unique ID. So let's save and try now. Okay, fixed. I think 90. Let's check this out. Correct. Okay, fix the syntax error in local 5 rules file and make it work well. Okay, let's see the file local 5. Sorry. Okay. Okay, we have 3 active rules here. We have 3 active rules. First of all, let's check the IDs. So we have, yeah, okay, the IDs are good. Let's start with the first one. Yeah. The first one looks good. Okay, this one is not right. This is not right here. This can't be like this. Yeah, so we need to do it like that. This is the right direction. And yeah, if we can notice here, sorry, here. Okay. The third one, this one. This is the right thing. Okay, so I think we are good to go. Let's save and try to run the, just we have to change this to 5 and then run. Perfect. The alerts 155. Let's try this out. And this is the correct answer. Okay, fix the logical error. Now it's a logical error, not syntax error, logical error in local 6 rules file and make it work smoothly. Okay, let's check this out. Local 6. We have one active rule, alert TCP any 80. This is the port, the destination port. Okay, get request found. Content and ID. Okay, get request found. Okay, so I believe I think the error is here. I have a feeling that the error is somewhere here, the content. So this is in hex hex format. So I think I have to make sure that this hex format is identical to the to get request. So we can like check if 67, 65, 47. Okay, this is good. Yeah, 67. This is get. This is get but in hex format. Yeah, but I think we have to add no case to the structure. So if we, let's try this out. If we add no case and try to run the command, what can we get? Okay, so this is the rule 6, I believe. Yeah, and let's run. We got 2 alerts, two packets. Let's try this. Correct answer. So the logical error was the no case. Yeah, we have to add no case to the rule after the content to detect the get request. Yeah, because the no case is an option that uh, can help us to detect the what we need and what is included in the content, and like uh, uh, without any problems with the whether it's in a capital letter or small letter. So the no case will solve this problem, so we can find what we are looking for without any problem uh, with this thing. Let's fix the logical error. It's another logical error in local 7 rules file and make it work smoothly to create alert. Local 7. So let's check this local 7. 7. We have one active rule, and here is 2E687. Okay. Yeah, but the message is missing, and this can't be. We should add message. Yeah, yeah, here. So, and we can add whatever we want. So this is kind of hex format for something. I'm not quite sure what is it, what it is, but what is the name of the required option? So as we say, like this is the message option, correct. So yeah, this is the task 6. The task 7 is using external rules MS17010. The MS17010 is an exploitation, and now let's try to answer these questions. So we have navigate to the task folder. Let's navigate to the task folder. It's the task 7. We have the task 7 here. Okay, so we have two rules file and the packet capture file. Now the question is, use the given packet capture file, use the given rule file, local rules, this one, to navigate the MS17010 exploitation. What is the number of detected packets? So let's use the given rule file, local rules, and the file, the packet capture file, this one, this here. All right. All right, so wow, the number is so big. It's 25,154 packets. So let's try this out. Okay, correct. Okay, so clear the previous log and alarm files. Use the local one rules empty file to write a new rule to detect payloads containing the \IPC keyword. What is the number of detected packets? All right, so let's clear this out. And all right, so we have these alert, and let's remove these two files, the log and the alert from the past command. And now let's open the local one rules. Alright, so let's write a new rule to detect payloads containing the \IPC keyword. I believe the \IPC dollar keyword is a keyword like keyword indicates to the phase before or the phase that precedes the M17 exploitation. It's some kind of reconnaissance. So we are going to write a rule to detect this keyword. So if we write alert the TCP and any and message we can write here. We can write RPC detector. Okay, the content should be the IPC and this. Yeah. Okay. All right. No, I think here, yeah, we need this whole keyword with the backslash. Okay, but the backslash is a special character in Snort, so we need to escape by adding another backslash here. So now we can get the whole keyword with the backslash. This. Okay, and this ID. Okay, and all right. Yeah, I just want to. Okay, ref. All right. So I think we are now good to go. Let's save it and try to run the command. Let's just add here the. All right. Okay, what is the number of detected packets? We've got the 12. Let's say the 12 here. All right. Now investigate the log alarm files. What is the requested path? What is the requested path? So let's investigate the log. This is the snort log. This is the log. Okay, so let's sudo snort. Maybe this one. And let's use this to get the header and the payload of the packets, so we can have detailed information. What is the requested path? All right. Okay, so this is the SMB a server message block. It's SMB channel is a network protocol for sharing file and other resources. So the requested path I believe is this one. Let's try this out. 192.68. Correct. So yeah, this is the requested path. What is the CVSS V2 score of the MS17010 vulnerability? Okay, here guys, we gotta do some like to do search. Yeah, external search to figure out what is the VSS V2 score of the MS17 exploitation or vulnerability. So let's write here the MS17 CVSS V2 score. We can see here the okay. So this is the CVE details. Okay, we are looking for the V2 version 2. We can see here, according to the NIST, vulnerability database, that the base score is is the 9.3. So we can try this out, and it's correct. So this is the score, severity score of the which is too high for the MS17 vulnerability. So guys, after doing the search, we found out that the score is 9.3. Now, using external rules for log4j, let's use external rules to fight against the latest threats. Now, answer the questions below. Navigate to the task folder. Use the given packet capture file. Use the given rule file, local rules to investigate the log4j exploitation. What is the number of detected packets? All right, so let's navigate to the task folder, which is the task 8. We have two files rules and the packet capture file. Okay. Local rules. And this is the packet capture file. Let's see. Okay, the number of detected packets here we can see 26. Let's try this out. 26. Okay, correct. Now investigate the log alarm files. How many rules were triggered? How many rules were triggered? So to investigate the log file. Okay, so how many rules were triggered? Okay, so let's try to read the file. This one. Let's see if we can find out how many rules were triggered. Okay, now here we are investigating the we are investigating the packets, but we need to figure out how many rules were triggered, how many rules were triggered, and in order to know that, I believe we have to read the alarm files, because yeah, inside the alarm file we can find um, uh, what is the triggered what is the triggered rule, and there are many I think alerts. So, and sometimes one single rule can like can produce, or if we can say produce like many alerts. So we need to figure out how many rules were triggered. All right, so let's write this. We can use the cat command to find out, or to read the alert file. Let's use this cat alert, and we can use grep option and the O, so we can read only the only matching part of our option here. Okay, so we can write this. So as we know that the the rule inside the alarm file is encoding a two brackets, and inside them we have the roll number, ID, and the revision, separated by columns. So we want to filter this to find out the how many rules were triggered. So we can say that this is the backslash to retrieve the brackets, and inside the brackets we have, as I said before, the numbers. It's the ID number, so it's 0 to 9. All right, and colon. Yeah, it's a number. It's a number from 0 to 9, and let's add the asterisk to tell the command that it might be like more than one digit. So, and here the same thing. And also here the same thing as well. And we need the bracket, so we have to add backslash before it, as we said before, because the backslash is the brackets are special characters as well as the backslash. So we forgot just this here and this one here. All right, now we will get the this okay. All right, so let's sort and unique, so that we don't have or we don't get the same output many times. So let's try this out. All right, so this is what we want actually. This is the rule ID, which, as we can see, each ID is like different from the other. So this indicates that there were four rules triggered. So let's try this. All right. So this is the correct answer. It's four rules. What are the first six digits of the triggered rule? Its IDs. We can see here that this is the first six digits, 2100372. It's the same. Oh, sorry, this is this first six digits. All right, clear the previous log and alarm file. So let's clear them out here and see this one and this one. Now they are removed. And the question is, use local one rules empty file to write a new rule to detect the packet payloads between to detect packet payloads between 770 and 855 bytes. All right, what is the number of detected packets? Okay, so we need to write a new rule. Okay, so we need to write a new rule to detect the packet payloads between 770 and 855 bytes. All right, so let's see the hint here. Okay, so the D-size option will help you to filter the payload size. Okay, so we need to use the D-size option. The D-size option. So let's write alert. TCP any. All right, and the message. Yeah, we can write here. Whatever you want, maybe TCP packets. And the option D-size. Okay, this option will help us to filter the size between 770 and 855 bytes for the payload. So we can write this between 770 and 855, and all right, this one here. Okay, yeah, I think this should be good. Let's save it and run the command. We need just to change this to rule -1. All right, let's run this. The detected packets are 41. Let's try the 41. Correct. 41 packets. Investigate the log files. What is the name of the used encoding algorithm? So let's see first what's the log name. This is the log one. Okay, so let's sort with this one. And let's use this option to get a detailed output. All right. So the encoding algorithm. All right. We can. Mhm. Okay, so the encoding algorithm. Mm. Mhm. All right. Okay, guys. So this is the encoding algorithm. Yes, this is the command, and this is the encoding algorithm. Base 64. Oh, sorry, it's here. Correct. So this is it's the base 64. Investigate the log alarm files. What is the IP ID of the corresponding packets? This is the packet, I believe, and the IP ID. Yeah, it should be this one. This is the ID. Let's try this. Correct. This is the ID. This is the IP ID. Yeah. Now, investigate the log alarm files. Decode the encoded command. So we need to. Sorry, where's the packet? Yeah, here. We need to encode the command. This one. This one. Yeah, this is the command that we need to encode to find out what is the attacker's command. So we need to copy this and paste it on the Cybersecurity and see what is the attacker's command. Okay, guys. So this is the Cybersecurity, and I copied the command, the base 64 command that we found in the packet, and paste it here. And as you can see, As we can see, this is the command. This is the required command. So let's copy this and paste it. Try to try this. Try to paste it there. And let's paste this here. Okay, so this is the correct answer. What is the CVSS v2 score of the log4j vulnerability? And I believe it's because I did a search. I did a search for the for this vulnerability, and I think it's the same score of the MS17. It's 9.3, and this is the correct answer. Okay, guys, and that's a wrap on the TryHackMe Snort challenge. To quickly recap, we successfully analyzed the packet capture file, identified the malicious traffic, and wrote a custom Snort rules to detect it. The key takeaway here is understanding how powerful a tool like Snort can be for network defense. And yeah, thanks for watching and see you in the next one.